Everybody, this is Nick Totaro, Professor of Information Technology and Computer Science at Lakeland Community College. If there's one question I hear a lot, especially in programming logic and in some other classes, in cybersecurity, when we talk about cryptography, is how much math is involved. Let's face it, math can be scary, but I will tell you, when we're dealing with certain things, obviously at a much higher level, when you're talking graduate level, maybe some extreme cryptography levels, yeah, you need to understand some pretty intensive math. But for the average application, the application development, IT, we're probably talking eighth grade arithmetic. I'm not being facetious here. We may occasionally get into a little trigonometry and do some formulas, but in reality, we don't crunch a lot of numbers at the lower level, at the IT level. Now, maybe at the computer science level, at the graduate level, or even the junior senior level at a CS program, yes, you're probably going to be required to understand some higher level math. But for what we do most of the time, it's eighth grade arithmetic, and I'm not being facetious here. In this video, I'm going to cover a concept that seems to cause people a lot of angst, but once you break it down, it is something that we were taught probably in third or fourth grade, and that's called modulo arithmetic. And what modulo arithmetic fundamentally is, it's long division where we concern ourselves with just the remainder. So let's go up to my screen, let's do some simple numbers, and let's see what we get from this. So I'm at my Python interpreter and I want to know 17 divided by 5. Well, we could do that one in our head. We know 17 divided by 5 will be 3, remainder 2. In modulo arithmetic, we're concerned with the 2, but let's do something real quick. So I'm up on my screen and I'm going to use a Python function called divmod, and I'm going to say 17 divided by 5. And it's going to return 5 goes into 17 3 times, remainder 2. Modulo arithmetic says we're concerned with the 2, and I'll explain why in a little bit, but fundamentally, that's it. It's long division that we look for the remainder. Now, we don't see it a lot of times because of our calculators. Many calculators don't have the long division function to it where we see the whole number and the remainder. Most calculators, you're going to see a decimal point. So we kind of fallen or gotten rusty with that technique. But if you go back to third, fourth grade and you basically say, what is a number divided by another? What's the remainder? What if it's a bigger number? Let's say I say dev mod 1963, and we're going to divide this by 60. So how many times does 60 go into 1963, and what is the remainder? And 60 goes in 1963 32 times with a remainder of 42. In modulo arithmetic, we would be concerned with the 42. Long reasons why, but fundamentally that's it. So is there a technique that I can use that will allow me just to get the 42? Yes, you've seen it in the textbook. We've talked about it in class, and that would just be saying 1963. We're going to use the percent sign. That tells us to use modulo arithmetic, 60. And we just get the remainder. Could we get the whole number? Yes, then we would just do a division. But again, in this video, I'm more concerned with the modulo arithmetic. So in modulo arithmetic, we are concerned about the remainder. Now, there's a lot of functions in Python that use the modulo arithmetic as an extra feature because it is used quite oftenly in cryptography and things like that. So one of them is the power function. So if I was to say pow, and that just means raise a number by another number. If I was to say pow 2 raised to 8, right? So 2 to the power of 8, 256. But we can also throw in a modulo arithmetic in this. And I can say, okay, I can say pow 2, 8. And if I throw in one more optional number, strictly an optional number, I'll say 7. So this is going to basically it's going to divide 256 by 7 and give us the remainder. Because again, we're only concerned at this point, we're only going to be concerned with the remainder. So it's going to return the remainder of 256 divided by 7. So if I divide 256 by 7, I get a remainder of 4. Now, if you take any of my cybersecurity courses, the Security Plus, Ethical Hacking, Forensics, we often use Modulo Arithmetic, and we specifically use this particular pattern. I don't care about that right now. In this particular video, I'm more concerned with you understanding when we're dealing with modulo arithmetic, we are just concerned with the remainder. Now, I'm going to do one more demonstration. I'm up here at my Replit IDE and I've created a really quick, silly little Python program. And in this Python program, it says, okay, give me a range, make I from 1 to 100, actually 0 to 100, right? Make I from 1 to 100. Okay, and then divide I by 17. And at any point you have a remainder of 7, there's our modulo arithmetic right there. Right there. It says divide I by 17. And if I get a remainder of 9, just print that out. It's a silly thing, but there's a reason, there's a method to this madness. And boom. There it ran, actually ran it twice. I must have hit the button twice, but it ran that. Now, what this means for us is that any one of these numbers that would be divided by 17 would give us a remainder of 9. We use that quite extensively in cryptography and in ethical hacking and in Security Plus because many times we don't want to share, we may not want to share these numbers. I'm not going to go into details about that, but I just wanted to show you that this is the beginning of cryptography in many regards because we're more concerned with the remainder than how we got to the remainder. So, recap. Yes, there is math involved in everything we do. You go down any field endeavor, not just ITCS, but you go down any field endeavor, you're going to be involved with math. In the ITCS world, I suspect in the early days of computer science, they were using computers as giant calculators because of the big and massive numbers and the total calculations that they were dealing with. And somehow that has grown into you have to be a mathematician to get into ITCS, and you don't. Many applications, most applications that you'd see on your phone, they're doing 8th grade arithmetic or maybe even trigonometry, nothing really severe. You'd just be plugging in formulas, etc. So this video was about modulo arithmetic. Recap on that. We're concerned with the remainder. We're dividing a number. We're doing long 3rd or 4th grade long division. We're dividing a number and we're more concerned with the remainder than the division. We don't use that a lot in our calculator world because our calculators want to divide things to the point that they get decimal points. So this is Nick Tero. Let's go and learn something.